Thanks everyone for joining us for this live event. Before we get started, just a few orders of business. This is a live event and we have Q&A enabled for the event. We'll be answering questions at the end, but feel free to ask them as we go. But please do keep questions limited to the topics that we're covering here, and we'll do our best to answer them. So I guess starting with introductions, my name is Cameron Cooper. I'm the head of developer product management here at Chia. And then we also have Dan Perry from Chia, who you will know for writing all of that great documentation that we have. And he's also going to be doing a demo later on here. And then we also have Amber from our partner Clovyr, who's going to be doing a demonstration as well. So today's presentation is going to be focused on developers. As the Chia ecosystem grows, we know that developers play a huge part in that. We want to work with the community to make sure that we have the tools and materials in place to make sure that those developers are successful. So to that end, we've been working on that, and we've got some things that we want to share with you. We know that one of the big problems that developers often face when getting started with Chia is figuring out where to get started and getting that initial development environment up and running. So we've been investing pretty heavily on that, working on more tools and documentation, but we also have been working with Clovyr in order to help solve that problem. And so for the first part of today's presentation, I'd like to hand it over to Amber to talk about Clovyr and what we've been working on with them. And then after that, we'll hand it off to Dan, who will also do a demonstration within Clovyr. So Amber.
All right, thanks so much, Cameron. Yeah, hi, my name's Amber Balday, and yeah, I'm a co-founder at Clovyr, and we have been working with the Chia team for past couple months, digging into the developer tool set that's available, the kind of current tool chain, where they're at, where they want to go. I think everything that's happening with the docs and ongoing examples and things has been amazing in making it more approachable. And also things are changing very fast. We know that with, the release of cats and, where everything is going. What we're working on at Clovyr is multifold. There's a much longer term kind of ambitious vision about helping people run their own infrastructure for, pretty much anything, and do that in a way that's frictionless enough that we can really reduce the technical skill level required for people to move on to self-hosted apps, right? So that people can choose based on the apps that they want to use and not based on saying that they're too scared. And that's why they're stuck in a walled garden SaaS platform, right? Obviously, that has a lot of implications to DeFi and across the, I'll call it crypto ecosystem. At this point, I've admitted we're going to just call it crypto. And so one of the first applications that we released on our orchestration platform is called Clovyr Code. Clovyr Code is a in-browser version of VS Code, but is backed by a full VPS that allows you to execute standard terminal commands and customize to your heart's content and treat it essentially as though you were on a local development environment. So you can kind of get all of the cool feeling of remote development with the privacy and convenience of a local environment. So that's what we have. There are, other projects. I think maybe GitHub Codespaces comes to mind as people that are trying to put VS Code in the browser. That's fine, good for them. But I think what you'll notice there is that you mostly are, you're pulling in a repo and maybe browsing it, but the ability to really interact and customize the environment is, it's completely limited if you're not behind the paywall. And even once you pay there, it's mostly an on-ramp to Azure. Our goal is to help people self-host anywhere. And that what you'll see, I'll demo this here in a second, is that ideally the user experience is such that people say, oh, this reminds me of a Git pod or a code spaces, and we say, yes, it feels that easy, but behind the scenes, none of your data is actually transmitted through Clovyr infrastructure. There's no Git authentication, credentials that is shared with us as a company or with anyone else, right? So it's not just, we don't have a privacy policy about it, we just don't collect it, right? And that's because you're able to connect directly from your browser to the infrastructure that you deploy. And nobody has really done that before, but we thought it was an important kind of architectural decision to demonstrate that privacy isn't a product, but better products prioritize privacy. So with that, anything else I should add there, or should we just kind of get into what's inside the Chia package here?
Yeah, let's dig in and talk about the Chia package.
Okay, great. And so what's interesting about working on projects in crypto Web3, I'm going to stammer every time. I don't know what we call it this week. So in this space is that there's a lot of new tech stacks, right? New languages, new communities that are bootstrapping developer ecosystems from almost zero, right? And so the pace and ability to onboard developers is paramount. It's a competitive advantage for these various projects. Just throwing an SDK at the problem isn't enough. We want people to not have to learn completely new IDEs. We don't want people to have to use, oh, we've got a browser-based IDE, but it's got 1/10 of the features, and now we have a whole team that's dedicated to like figuring out how to get all of our RPCs active, like in this, it becomes an entire product and project to work on. So instead, we wanted to bring the convenience of modern development to the domain that we're working on. So let me attempt to share a screen here. So what I'm going to share, let's see, can we share? Let's see. Hopefully I am. Okay, so what I'm showing you now actually is the top level of Clovyr.app /code. And this is the beta that we've had available for some time now, where you can one-click launch environments for a variety of standard languages. So these come with all the kind of packages that you would expect to see if you're working on a well-established language. Now, when we're working on a project like Chia, there's additional requirements. Like you want to see connectivity to a test net. You want to have your specific command line tools available. So are we seeing the Chia Clovyr code launch page now? Great, okay. I was glad I shared the window and not the tab. Okay, so from here, and this is available now at Clovyr.app /instant I think code Chia will redirect here, but don't worry about the link. You're gonna see it in blogs and all over social media and what have you. So we'll get you the direct link. But once you're on this page, what you'll see basically is you can go learn more and read all about it, or you can launch now. And what's going to happen when I click launch now is going to happen very fast. So it's going to seem like nothing's happening, but stuff is happening. So what's going to happen is that we're actually going to provision a full private to you VPS in the background, which is going to be provisioned with VS Code here. We're cloning in a repo that has a bunch of docs and examples specifically related to Chia, and which can be a community effort over time to evolve. This is not in any way owned by us. The goal here is to kind of evolve and grow with additional examples. And that's it. So we've cloned in a public repo, and because of that, we could, simply browse it. And if you wanted to, you could take a look at some examples that are there already. Some popular ones, I think, already are, there's a checkers one, a piggy bank one, and the leave a legacy one is new and very helpful. And so from here, what we're expecting the level of knowledge to be is basically that you are interested in learning more about Chialisp. And that we do not expect that you have already built and already deployed applications or coins to testnet or mainnet, right? So this is geared towards people to whom this is new. If you are a power user and you already know exactly what you're doing, then good for you, just kind of get right going. All of the tools are there. So I will step through kind of the first things that I would suggest that we do. I'm going to take the lazy route and copy paste this here. So the first thing that we want to do right now is I'm just going to make sure that we're pulling in. Okay, so we have the most recent repo. It's already up to date. We're adding new examples right now. Over the next couple of weeks, we're really polishing this up and taking community feedback. And if you have suggestions, you can submit them. And so that way we're all on the same page about what we're looking at here in this repo. And then from there, I'm going to run one initialization script, which is going to initialize the Chia testnet here. We pulled this into its own script so that there's no duplication of keys across users. So you do want to start with this one. So it's going to just do that, create some keys for you, and from here you're ready to go. So we're just going to do Chia Start node. And that's it. You have a full node on testnet 10, which is now started. It's going to start syncing in the background. So because we're on testnet, we're able to import the existing SQLite database. So you wouldn't want to do that for mainnet. So that does allow us to save a little bit of time on syncing a full node. But it means that when you use this, it's like ready to go instantly. Once you've done that, which I would suggest that you do at the beginning of when you start this, of when you launch an environment, it'll take about 5 minutes to probably sync up to the current block height. If you don't, and instead you click around and like you work on things for a while, and then you walk away for 3 days, and then you come back and you never started the node, you're going to have an outdated version. And so at that point, we have a couple tips in help as to how to just re-pull in the latest database file. It's not a big deal. And if you haven't done anything yet, you could just destroy this environment and launch a new one and get the latest version too. Like, no harm, no foul. Like, these are meant to be ephemeral. You'll notice I didn't sign up for anything. I didn't put a credit card number in. Like, this is because it's a public repo. I haven't even authenticated to GitHub. So it's just, I am just a person on the internet who is accessing something via Git, right? Okay, so we're here. So let's see what we have. So we started our node, and from here, I think we want to just do Chia show. Let's see if we have connections yet. We should get them. Making sure I'm following the right thing that I'm doing here. And if we wanted to make sure that we're following the right thing, in case you forget what, oh, there they are. Look, we have 2 peers. The steps to do all of this are actually embedded in here, right? So I suggest that you open this page in a separate tab, which is what I actually did, just so that I can make sure I'm following the runbook exactly in the same order that you would be doing it. So if I click this, it'll open it in a new tab. But if you want to just poke around the actual, the files, I mean, this README is right in here. So if I'm doing getting started, I can open the getting started page right here. And an interesting, this is a key command for VS Code if you're not familiar, but just Control-Shift-V will put you into pretty mode. So any markdown files will then render really nice. So from here, you can see what we're doing. So we just did Chia Start node. We showed some peers. We can go ahead and show our sync status. If I could type, that would be amazing. And so it should, in the background, just begin syncing up to current height, right? At first, I think it'll reach out to about 2 peers over 1 minute. If you let it run for like 10 or 15 minutes, it's going to usually reach out to like 6 or 8, and the speed will increase. So all of that just happens automatically, which is pretty cool. And from there, you're basically ready to begin using the new wallet. The new Light Client wallet that the Chia team recently released is crazy fast. And so it eliminated what was previously like a pretty big hurdle in us cutting down the time to get up and running. So to do that at this point, let's see, how close are we to being synced? We're pretty close, but we can do our Chia keys generate, I think. If Okay, so we're gonna generate some keys here. Of course, this is on the test net and you can see my fingerprint, whatever, it's not a big deal. There is a process to go get some test mojos and things, which we'll be updating over the next week so that you can just do it right in line here. Currently, you can just pop over to a web faucet and do that. And so once we have generated some keys, we can see if we're ready to start our wallet. Okay, and now we should be able to show it as well. Ideally, it needs to sync up a little bit. So sometimes you need to wait like 30 seconds there. There you go. You see it's syncing, right? And so we have a zero balance. So at this point, if you want to work on deploying an existing example that you found on the internet or that you've created, you can basically just go from here. Just pop some test mojos in there and you're basically off to the races. So that's cool. Is there anything else you'd like me to showcase?
No, I think that was really great. And I think Dan is going to run through a lot more of the tooling in detail. So we can hand off to him here in a moment. But yeah, this is really exciting. I think that, from our perspective, for having a one-click sort of instant environment with a full testnet node already fully synced in there with all the Chia software and all the Chia development tools and all the Chia Lisp tools already ready to go with one click. I think that's
Yep.
Really exciting from our perspective and something we're just going to drop right into our documentation pages so that a developer, as they're learning about Chia development and want to try it, have a really quick way to get access to it.
Yeah, so this would be normally this could have taken you, if you were sorting through READMEs the first time, easily 2 to 4 hours on a good day. So hopefully this saves people a lot of time. I want to highlight one more feature, just because I know this is happening on the web. And so people have gotten a little confused about whether or not, like, where is it coming from? Is it like a web app in the sky? But it's really just like your local environment. So just imagine that anything that you would want to do there, you can do here. So if you want to pip install something, fine. If you want to use npm, you can install it, whatever you want. So if I were to say, like, let's just go back here. This is going to become relevant slightly later in your presentation. I just want to show that you're not limited to the repo that's in here. This is an example repo, but you can clone in whatever you want. So I just happened to create like a public repo in my own account, right? So I can just drop that in here and it will just pull in alongside, right? And so now I have Chia Test was the name of my little repo here, right? So you can pull in your own repos, and then when you want to commit and push back, that's when you will need to actually authenticate, or if you try to pull a private repo. So I'm sure there will be some questions about that as we progress, and we're happy to answer how to generate a token on GitHub to replace your password and whatnot. But the world is your oyster, so clone your repos and have fun.
Great, awesome. Thank you so much for showing that. Dan, are you ready to dig in and do a bit of a demo using Clovyr?
Yeah, all set, Cameron. Thanks. To start out, I'm gonna assume that there's a pretty big variety of experience with Chialisp within the audience. Like, some of you might be really familiar with it, some of you might just be getting started. So the way I'm going to structure this is to talk a little bit about the differences between the coin set and the account model. And Chia uses the coin set model, and Ethereum and most other smart contract platforms use the account model. I'm going to talk a little bit about the differences and why I think the coin set model is so much better, and get you a little bit familiar then with Chialisp, and I'll go through an example of how to build something, and hopefully we'll get something, a coin actually put on the blockchain, and then show you how to spend it. And this is all going to be using Clovyr, and hopefully this will take around 45 minutes, so you're ready. And I'm going to share my screen right away, and okay, good. So to start out, if you've probably seen a lot of the headlines if you've been in the space for any amount of time, where some DeFi contract gets hacked or attacked and money gets stolen and accounts get drained. And this just seems to happen all the time. And I guess mostly because we're in this bull market, that the market kind of shrugs it off and just thinks it's somewhat normal, or maybe they blame developers for developing bad smart contracts. They try to plug security holes, but I think it's really just the system itself that's quite flawed. And so this is where I want to go into a little bit with, one second, I have to resize my screen here. A little bit with the, oh, there we go. Sorry, I had trouble changing tabs. Talk about Ethereum just a bit here. And I'm not necessarily picking on Ethereum specifically, but this is just the most familiar that you guys are probably most familiar with it. I have here a contract on Ethereum, and this is for the Meebits. And Meebits is the follow-up for the very popular CryptoPunks app, DeFi protocol. So this contract for, sorry, one second. This contract is going to be sitting here on Etherscan. This is a blockchain explorer for Ethereum. And most of the contracts that you'll find on Ethereum, they'll just put the contract right here in code. But if I wanted, I could go ahead and just copy the address of this contract and go to a decompiler and paste the contract right here, decompile. And now I can just, once it loads, I can just see the contract itself. Well, I guess I won't go through this. It's taking a few seconds. But I could just here it is, very briefly, very easily decompile any contract and just see the code sitting right there. So this is kind of a big flaw with the account model, where you have a contract sitting on top of the blockchain, and the compiled code itself is viewable for anyone. And what's in that code? This is kind of the meat of the problem here. You have functions like this one here, this accept trade, and this I have highlighted here, this ETH balance. This is where the money sits, and so this is just an array, and it has anyone who has joined the Meebits contract will have money sitting in this array, and everybody's money is together all in one array. So there's no sandboxing whatsoever. So if anyone is able to get into this function and exploit it, then they could just potentially drain not only one person's money, but everybody's money all together. So this is kind of a really big problem that you see across the board. And I'm not picking on Meebits specifically. This is just, this is a very normal way to do things in Ethereum. And just before I move on to Chia, I don't think this contract has been actually exploited or hacked in any serious way. But when it first came out, a guy did figure out how to learn what some of the features were going to be that will for certain Meebits that would be really rare. And he did a grinding attack where I have that right here. He would mint a Meebit, and if it wasn't going to be valuable, he would just cancel it. And these are all the cancellations that he did. So I could just look at one of these, and he would just pay the transaction fee, which here was like 41 bucks. And he did this a couple hundred times. So he spent several $1,000s canceling. But what he ended up with was this really rare Meebit, which then he sold for like $700,000. So even the really big contracts have some security vulnerabilities within them. Okay, so I think the big problem, though, that I forgot to mention here is in Ethereum and in any sort of account model, the money sits inside of the contract. So the money itself is a second class object. The contract is your first class object. The money is a second class object. So let's contrast that with Chia. And so here I have Clovyr all set up and ready to go. And I need to move something out of the way here. So Clovyr's all set up right here. And I have created a couple of keys already for you guys. And when you install Clovyr, as Amber pointed out, you have 3 examples here. The first one we have is checkers. Second one is the piggy bank tutorial. And this is something that Quexington created a while back. And he created a whole video series for this. So I definitely recommend that you go watch this. And then this is Leave a Legacy, which I created a while ago too. And I did a whole a much longer video tutorial than what I'm going to give you today. But I think probably most of you haven't seen this because I just did this on my own as a side project. So let's look through this here. This is what we're going to do today. We're going to look through Leave a Legacy, and I'll show you how to build it and deploy it. And to start out, what is this project? This is going to be trying to solve a real world problem, which is when you die, or when somebody dies, what happens with their cryptocurrency? I think this will be an issue going forward in time because if you don't have a great way to pass on your private keys, then that money could just be bricked. And so what I've created here is a smart coin, and I have a whole README here, and the basic coin is just this. So there's only really 2 rules, and the first rule is if let's say this is Alice's coin, while Alice is alive, only she may spend the coin. Second rule is after Alice has died, anyone may spend the coin as long as they follow the rules of the inner coin, should one exist. So here we come to one of the really big advantages of Chialisp, where you can have inner coins. You can create coins inside of coins and wrap them. And you can make much more complicated examples like this one, where you have a coin inside of a coin inside of a coin. And so this innermost coin has to obey all of the rules of the outer coins. And you can mix and match, you can put any coins together. So this gives you a lot of flexibility in how you can develop with Chialisp. I'm not going to go through this whole thing today. I'll just go through building this one right here. And the one thing that's missing from this is, how do we know when Alice has died? And I don't have a great way of knowing that right now. We would need some kind of oracle to figure that out. But this is potentially something that someone could build where, like one idea would be to figure out how to take a death certificate and hash it and put it onto Chia's blockchain as an NFT or something like that, or a singleton. Let's go back to the code and just show you how this is going to be built. And I'm not going to run through the entire thing. That would take a little too long, but I'll just go through it very briefly. This is the main Chialisp code for this smart coin. And the way Chialisp works is you have your puzzle, which is all of this code here. And then you have the solution, which is something that you pass in. This is the solution. In order to spend a coin, you have to pass in a valid solution. You'll notice that some of these things are capitalized, and that is done because that's just a convention to make it more human readable, to indicate to people reading it that these are curried values. So currying is something really common that we do all the time in Chialisp, and that's a way of pre-committing certain values to a puzzle. It's not quite hard coding like this. Oh, I forgot to mention, I don't have that oracle, and what I have here is wait time, and this is just going to take the place of an oracle. So this is going to be like a time lock function where after a certain amount of time, we'll just say Alice has died, just for this example. So I could theoretically like do 1,000 seconds, just hard code that in and hard code throughout the whole puzzle, this value, and then I wouldn't need to curry. But the problem is, what if I want to change that value a little bit, make another coin? This is one thing with Chialisp, like that's different than Ethereum or an account model, the coin set model. Every coin is independent of every other coin. They're strongly sandboxed. So what I can do is keep making new coins with different values, right? And so it's a really nice function to be able to pre-commit some values to specific coins. Okay, so the first 3 are all pre-committed, or curried. The second 3 are not. I'm just going to run through this puzzle really briefly here and show you what it does. We have a couple of libraries included, and the first one is condition codes, and that's right here. We have a bunch of conditions that you're going to need to, that you could potentially run as part of your spend, and all that Chialisp understands is these numbers, and these codes just make them more human readable. So this is a really common thing to include in your programs. And the other one is SHA-256 tree. this is going to create a tree hash or a puzzle hash of whatever you send in. So this function uses recursion, and here it is. And so this is another very common one that we use in puzzles. Recursion is a very normal thing to do in Chialisp. So if you want to develop in Chialisp, you have to get used to recursion. And the way this works, I have here this tree where in Chialisp and in any Lisp, everything could be broken down into a binary tree. And so this is a visual example of what that tree might look like with only a few levels. And so this SHA-256 hash function is going to hash the leaves of the tree and then hash them with the branches and then the leaves and make its way all the way up to the top recursively until it gets one final hash. And this is very important in Chialisp to creating coins. Okay, the rest of the puzzle, we have some functions. We have a function here, we have a function here, another function, and at the very bottom is our main code. And usually with Chialisp, the main code is going to be at the bottom. Okay, so what this does is the first thing that is curried in is the public key of the owner of this coin. And so here we'll say Alice owns the coin. So that is going to be pre-configured or pre-committed to this coin. And it's going to do an if statement. And if these two are equal, the way it works in Chialisp is this is the then clause, this first one, and then this is the else clause. So if Alice, this will be Alice's coin. If Alice is attempting to spend the coin, then we'll do this. And if someone else is attempting to spend the coin, then we'll do this. Now, let's look at the first clause first. Sign and execute inner. So this is where Alice is trying to spend it. And the first thing that you'll see here is we have an egg sigmy. So Alice has to sign this transaction using her private key. So this is basically verifying Alice's identity. And as long as it's her, then what I'm going to do is give her root access, basically. I'm going to let her do whatever she wants. So she can create an inner puzzle, and this A means evaluate or execute, and there's an inner puzzle and an inner solution. And she will typically just send the money to herself, and I'll show you in just a minute how that is done. So what if somebody tries to impersonate Alice? So like Bob comes in and has Alice's public key and sends it right here. So these two keys match up, but then Alice won't be able, or Bob, I'm sorry, won't be able to sign using Alice's private key because he doesn't have it. So the spend will fail. Okay, what about if somebody else is trying to spend it? Well, then in this puzzle, you get completely different functionality, which is kind of a cool advantage that you can do pretty easily in Chialisp. So this is going to check for an inner puzzle hash. So it's going to see if the coin looks more like this, where there's some inner puzzle. In our case, for just example, I'll just do this. But this function is going to go and run right here. The first thing you'll see right here is this assert seconds relative wait time. That is simulating Alice's death. So if Alice hasn't died yet, then this will fail, or if that time hasn't expired, this will fail, and the coin spend will fail, okay? So because this is not Alice spending it. If, let's go back to the rules, if Alice is alive, only she can spend it. So only once she has died can someone else spend it. Okay, so the next thing it does is checks for that inner puzzle hash to see if there's an inner puzzle. If there is one, it needs to make sure it's the right one, and that's this next function up here. I won't go into too many details there, but then if there is no inner puzzle hash like we have here, then Bob can just, or whoever can just spend the coin using an execute and inner puzzle and inner solution. Okay, so I know this, I really breezed through this. This is very fast, but you can watch my longer tutorial after this if you want. It's a couple hours long, going through much more detail of how this works. Okay, so let's take a look at how this might be executed. So first, we're going to need to curry these values. Let's make this terminal a little bit bigger. Actually, first I need to do cdv clsp build and leave a legacy building that puzzle. Okay, and oh, actually I already have built it. but this would compile it. So I get a hex compiled version. Next thing I'm going to do is query those values. So what I need is Alice's public key, which I've brought up already right here. And let me move this. So I'm going to do cd cdv clsp query and pass in that puzzle. I'll give it the hex file so that I don't have to compile it again. And -a for arguments. And the first argument I need is this owner pub key. So we'll pretend that this is Alice's wallet and this is Bob's wallet. So public key is here, and I need to add a 0x for bytes and put it there. And this first -a then will correspond to the first value in the solution. So the second value in the solution is wait time, and the third one is inner puzzle hash. Wait time, let's give it like 700 seconds. And the inner puzzle hash, I'm just going to leave that empty, as I said before. So I'll just enter an empty value there. Okay, so this is going to query the puzzle. Here's what we come up with. We have the CLVM version of what I just built, created up here. This is the lower level language of Chialisp. This is obviously not very human readable, but this is what you can change into that binary tree. And so some of these values like 2 and 4, these correspond to the leaves in this tree. All right, so that's the code. And this is where the really huge benefit of the CoinSet model happens. I'm going to take this code and I'm going to do a tree hash. And so that's going to hash that entire tree, all of the leaves, all the way up to the top. And it gives me this one value here. This is where Chia really shines, because money in Chia is a first-class object. I have taken this code and just hashed it, and that is money. The code turns into money, essentially into a coin, which has value. Now, this is the puzzle hash of that coin that I'm going to create. If I go over to this window here, there are really, Chia is really simple in terms of how its coins are created. The coins only have 3 values. There's the parent coin that creates it, which we'll figure out what that is in a minute. There's the puzzle hash, which I just determined, and an amount or a value. And you just hash those 3 together, and that's how you get the coin's ID. And so I have turned source code into money using Chia because it is a first-class object. Okay, let's take this puzzle hash and turn it into a wallet address. Okay, so CDV encode, and I'm going to use that, and I need to give it a prefix of TXCH because this is running on the test net. The default will be mainnet. So that gives me a TXCH address. And so this is basically like a wallet address that you can send money to, just like you would send money to your friend with their wallet address, except this wallet address will have to follow the rules that I've just laid out in this puzzle. Okay, so let's go ahead and do that. So we're going to do Chia wallet send, and we need to send an amount, and I want to go with, let's put in some zeros. I'm going to send, I'm not sure how many mojos that is. Let's just try that. I'll go for about 1,000 mojos. And I need an address to send it to, and I'm going to send it here. Okay, hopefully this works. Okay, so I have 2 wallets, right? One is for Alice, 2 is for Bob. I'm going to use Alice to create this coin. All right, so I've just sent it out to the blockchain, and that's going to be money that's sitting inside of this address in the form of a coin. So how would I go about spending this money later on? Well, okay, first let's say Alice wants to come up and try to spend this. How does she do it? So let's go back and get that, do that query statement again. Okay, so we end up with this Chialisp code. and we copy this. And by the way, this is all being done on the command line. Obviously, if you built a larger application, you'd have some hooks going into this, so this would be much better automated, but this is just a demo. So the command to execute the CLVM code is run, so that I'm going to paste the puzzle, and now I need to come up with a solution to the puzzle. So the solution is right here, and I've already curried in these 3 values, and you can actually see the puzzle hash right here. You can see that wait time right here. I need these 3 values still to be passed into the solution. I'm just going to send in for now a blank puzzle, a blank solution, and I need a public key for whoever's going to try to spend this money. That was Alice. So what was her public key? Was right here. Okay, and I need a 0x so this is interpreted as bytes. All right, so what just happened? It spat out a condition code, which is 50. And if we go over to here, this is chialisp.com, and I'm on the second tutorial here. This has all of our condition codes. And 50 is ag sigme. So that's where I need to get a signature for Alice. So Alice has to sign off this coin, and then she can spend it. But I haven't actually done anything. I've burned the coin, but I haven't used that money to create anything new. So you have to be a little careful here, because if I did this, all of this coin would just go straight to the value would just go straight to whoever farmed it. So because it's just left over, money cannot be destroyed in Chia. So what Alice can do, though, she basically has that root access to the coin. She can create her own inner puzzle and spend it however she wants. So let's try to do that quick. I'm going to create a new puzzle here, and I'll use a quote and a dot and a list inside of a list. And let's go back to the codes here. I'm going to create a new coin and send that to Alice. That's a 51. And 51 puzzle hash and amount is what I need. So 51, and I don't know Alice's puzzle hash, but let's just pretend it's this, just Alice, and amount, let's try 1,000, just to test it out here. Okay, so I've got I now have, in addition to that aggregated signature, I now have a new coin being sent to Alice for 1,000. Okay, so that's if Alice spends it. What if Bob spends it? Tries to spend this money. Okay, let's actually get Bob's real puzzle hash. So I go back up to that wallet. Where was that? This is Bob's wallet address. Okay, CDVD code. I'm going to turn that back into a puzzle hash. Okay, here's the puzzle hash. Let's copy that and rerun this spend, but with Bob. Okay, so this is Bob's. Actually, this is going to be Bob's public key that I'm erasing here. Let's put Bob's real puzzle hash into this new coin. Okay, and where is Bob's public key? Let's grab that. That was right here, master public key. This does take some getting used to. There is a lot of parentheses and a lot. It can feel a little clunky at first, but you start seeing how powerful this is once you start using it. So here's an example of that. I just put in Bob's public key, and now these condition codes that got spat out are different. So when Alice tried to spend it, she needed this to sign. When Bob tries to spend it, he gets this 80, which if we go back, 80 corresponds to assert seconds relative. So that's waiting for Alice to die. So first Alice has to die, and then Bob can spend the money, and he can send it to himself. Okay, so now that we've done all of that, let's go ahead and try to spend this money. Well, we need to create what's called a spend bundle, which is a transaction in Chia. And I have a spend bundle set up right here. You need to have some information about the coin and the puzzle and a signature. Now, I'll have Bob spend the money, so he doesn't need to sign this. So I go into more detail in the longer tutorial of how to do that. Let's get a couple of values right away. The amount was 1,000 that we wanted to spend. Hopefully I created the coin for 1,000. I just put a bunch of zeros in when I did this right here. And what we need is the puzzle hash for the coin. That was right here. So copy that, and I'm going to paste that right there. And the puzzle reveal and solution. So what you need to do in Chia is what goes on the blockchain is simply the puzzle hash or the actual coin ID, which I showed you how to create. Let's look at an example of that quick. This is Chia Explorer, and if I look at coins, I'll get some recent coins that have been created. Let's go to one of these. Okay, so this is a coin that just got sent. So what does this coin look like? This looks like, well, you see a puzzle hash here. What is this coin doing? Is it just a normal coin that's being sent to a normal wallet? Is it a smart coin with functionality like I just put in? It's not really possible to know because hashes are not reversible. And if you're examining the blockchain, all you see is this. Whereas contrast that with what I showed you before with the Meebits, where you can see all of their source code by decompiling it all. You cannot do that in Chia. So you don't know what any individual coin is doing. Okay, so, but what you do need to do is reveal the original puzzle when you try to spend the money. Let's go down here, and I'm going to rerun that query command, and this time I'm going to put in a -x, and that will give me the bytes for the puzzle. And copy that. So that is the puzzle in byte format. And now I need to get the solution, which I just came up with. So this was Bob's solution right here. Let's copy that. And I need to get bytes for that too. So to do that, I do an opc command. Okay, paste. And that gives me these bytes. Okay, there we go. And finally, I still don't have the parent coin info. Well, let's get that puzzle hash once again. I'm going to query the blockchain because I remember I created this coin on the blockchain already. Let's see what it looks like. So we need to do a CDV RPC coin records, and we need to go by puzz hash, and we will paste. Cool. So there's this coin sitting out there that I just created. Oh, I actually created for 10,000 mojos. That's all right. I'm only going to send 1,000 back to Bob. The other 9,000 will go to a lucky farmer. It has not been spent yet. And this is the information about the coin. This is all the blockchain knows about what this coin is. It cannot tell what the coin does until it has been spent. So what we still need to finish this transaction is the parent coin, which is here. And let's put that here. Okay. So now we have all that we need. And if I did everything right, I can now spend this coin. And what I'm going to do is simulate Bob spending the coin and sending the money to himself. So what happens if I do that? So CDV RPC push TX, and I'm going to put in that spend bundle that I just created. Spend bundle.json. See if this works. Okay, so I get a false, and I'm not quite sure why. I must have copied something wrong. I was actually expecting it to fail, and that's because that time lock had not expired yet. But this is failing for a different reason. But unless I can figure this out right away, I guess you got to be ready for this in a live demo. If I copied anything wrong here, it's not going to work. So how about?
Hey, Dan, do you need to set the coin amount correctly?
Is that it? I think it would just burn the rest, but let's just try that.
Your create coin is for a smaller amount, but I think this coin needs to be correct.
Oh, so 100? Live tech support here. Let's try it one more time. Otherwise, I'll just pass it back to you.
Or is it 10,000?
Yeah, I think I must have done something else wrong. I was a little nervous getting started here. So this, oh no, you're right. You're right. Okay, cool. Thanks, Cameron. Cameron saved the day here. It's so I did need to push 10,000. Okay. Assert seconds relative is still failing. So that means that Alice's simulated death has not happened. It must be that 700 seconds has not yet elapsed. If I were to go back and run this in another minute or two, it would pass eventually. So I think I'll leave this up and we'll try again in a couple minutes. But why don't I pass it back to you, Cameron, and we can go on to questions.
Yeah, cool. Yeah, so this is great. Thanks for walking through this demo. I hope that this is really useful to everybody watching. I know that Chia Lisp can be a little bit intimidating, especially if you're not familiar with the CoinSet model, or if you're not really familiar with Lisp, or if you just haven't done anything with Chia Lisp in the past. Seeing sort of an end-to-end demo, I think, is really useful of constructing that puzzle, spending a coin to it, and then creating another spend with that puzzle solution. So thank you for doing that. For anybody who's watching and wants to be able to revisit this, we're recording this and we'll end up posting it to YouTube, and so you'll be able to come back and check this out. Hopefully all of that made sense. I know you went through some really important concepts like currying, and I think currying, you described it correctly as sort of baking in some of the parameters, but it can also be a really important thing to do from a security perspective. So in this case, making sure that Alice's public key is hard coded and not passed in, because that would be a pretty big security hole. And so
yeah, actually, Cameron, maybe I could just really quick show you one more thing that I forgot to mention.
Yeah.
Let's say you're auditing this code. This was the Solidity code. You have to assume that people are going to try to call this contract from outside using other contracts. So there's so many things that can go wrong here. There's a ton of variables being passed in. A lot can happen, and it's happened many times where a contract on Ethereum has been professionally audited and it's gotten the green light, and it still has had flaws in it that have been exploited. How would we audit this? In a very quick way. What could someone, a hacker or a farmer who sees this puzzle coming through in the mempool, what could they possibly do to change this puzzle? If they change anything down here at all, then when I hash that puzzle to create a puzzle hash, it will create a different hash. So it will be literally a different coin that the farmer or hacker is attempting to spend, if they change anything at all. Except they could change the solution. That's the one thing that they could modify. But these three values have been curried in, as Cameron just said. So a hacker cannot change the key, the public key of the owner of this coin. But they could change these three. If we look at it really quick though, what happens if they change this inner puzzle and try to send the money to, like a hacker tries to send the money to themselves instead of to Alice or Bob, or whoever? Well, where's this inner puzzle used? This is just a method, a function call. It gets used here. But in order to use this inner puzzle here, you have to have Alice's signature, and it's absolutely required. So a hacker, there's no way they could ever execute this command because her signature is not there. If it comes up here, this is actually an interesting one because this is the case where there's no inner puzzle. And here, I actually have this baked in that if Alice has died, then anyone can spend the coin. So in fact, the way I structured this, a hacker could come in and spend the coin in that case, but that's by design. And if I had a more complicated puzzle like this, then that would not be possible. And the final case would be up here where I didn't go through this before, but the inner puzzle would have to match what I hashed in as a curried argument. So the point is, if a hacker tried to come in and change any of these three values, which are the only three that could possibly be changed, either the spend would fail or it would pass by design. That's actually the behavior I wanted. So it's actually in Chia Lisp, it can be tricky to write this code, but it's actually really quick to audit it. Like I did just now, that these are the only things that you could possibly change. And why don't we just really quick, I think maybe 700 seconds has passed. See if I can spend that money now using the exact same command. Yep, there it goes. So that simulates that Alice has died, and now the money has gone through. So back to you, Cameron.
Yeah, awesome. So thanks so much for running through that. Super helpful, and I hope everybody else enjoyed that too. So I think that concludes the Clovyr portion of our demos. We have one last thing that we want to announce today, is that we're actually going to be kicking off a developer challenge to help celebrate this partnership. This developer challenge is going to be an event that is going to be focused on writing code in Clovyr using their development environment for Chia. It'll be an online event over 24 hours. And there will be prizes either in crypto or fiat based on the winner's choice. And so what will happen is we will open up registration for this event this coming Thursday. We'll leave registration open for a while, and then we will kick off the event, and we'll at that point announce the details of the challenge as well as prize money. But now is a good time to start poking around, getting familiar with Clovyr and with Chialisp as well. So that is the bulk of the presentation. I know we have a few questions on the Q&A, so let's get to those as well. If anybody who's listening has questions, now's the time to fill them in. I think that we may have kind of answered some of these along the way, but Andy was asking, is the CLVM command line stuff included? And I think, yeah, as you saw here, it is included. And I think you had another question. So the entire smart contract can be created offline and then spent instantaneously. I think that's a pretty fair way to characterize it, as opposed to something like Solana or Ethereum, where you have the contract sort of living and running on blockchain. You actually would write this Chialisp offline and execute it or compile the puzzle hash that way. So it's definitely a different model, and hopefully that distinction is clear.
And on top of that, you have in Chia, you have smart coins. You don't have smart contracts per se. So
Yep.
each coin is individual. Like I just created one coin specifically for Alice, and nobody else can get into this code unless it's been designed that way. So it's very strongly sandboxed. You don't have many people accessing the same code that lives on the blockchain like you would in Ethereum.
Yep. Yeah, absolutely. Any other questions, or should we call it a wrap? Anything you wanted to add, Amber, here at the end?
Well, yeah, I mean, this was really fun to watch because I mean, we've populated it, with the examples that we're aware of there, and I was able to make it through the entire piggy bank example, so I feel like I have a reasonable grasp of creating a Chialisp contract and deploying it to the test net. So go me. But this was really fun to like see that it has all the things that you need. And yeah, so CDV is in there. Obviously you saw Chia was in there, run, be run, and we added the cat command line stuff as well recently. So, and if there's anything else, happy to put it in. So very excited about the developer challenge.
Great. Yeah. So we will be posting a blog post very shortly about this announcement, and as well as a developer challenge as well. So please keep your eyes out for that. All right. Thank you, everybody, for attending.
Thanks.
Thanks to Amber and Dan for presenting.
Thanks, guys.
All right. Bye-bye.